All right, now I'm ready, I think. We'll try it. And I am videoing this, meaning that it's recording the screen and my voice. I wish it could record you guys as well, so your parents can come back and watch and see behavior and stuff like that, but it doesn't yet. But they will be able to hear what's being said in case you want to look back at this later. So I'm just going to give it a shot here. All right, what we're doing today is what?
I don't know what that's called, but I know how to spell it.
Okay, does anybody know what it's called?
Oh, no.
Finding the variable.
You are finding the variable, and this particular type of problem is called a proportion. And we've had proportions quite a bit this year, but normally we have whole number values in those spots. Now we have some fractions. Talon,
Can't solve it.
go ahead, tell me what we need to do.
Okay, you'd make 2 1/5 into a, I forgot what it's called.
Improper fraction?
Yeah, improper fraction.
So that would become 11/5.
And you gotta make the bottom one improper fraction.
Okay, so we go 4 times 1 is 4, plus 3 is 7/3.
And then you divide them.
You can, but the process we used was called the butterfly method. Remember the butterfly method when we take our variable terms times the diagonal? And you can do this when you have an equal sign between them. If we had a time sign, we wouldn't be able to do this. But we have an equal sign, and so you have 11/5 x, and that's going to equal the product of the other two. 7 times 4 is 28, and 9 times 3 is 27.
So would it work so if you divided 11/5 by 7/3?
Say it again.
Would it work if you divided 11/5 by 7/3?
And then did what?
And then, I forgot how I did it.
Yeah, you can get there doing it, it's just the process. Longer. Sienna, what do I do now?
Well, what if it be 7/4 instead of 7/3?
Yes. Thank you. When I change that, I put the wrong denominator. So it'd be 7/4. Thank you. And then this would become 36. Right, okay. Now, once you've done this, Kylie, what do I need to do to solve?
Hmm.
28/36 times 5/11. We want the reciprocal of your coefficient. So times 11/5. Doesn't look like anything reduces to me. So we just multiply across. And you can use your calculator at this point. It'd be a good idea. 28 times 11 is 308. What now? What do I do? Oh!
I guess we'll parents will see this.
Yeah, your parents can see how poor your math teacher is. That's
awesome.
28 times 5 is 140
Attaboy.
over, thanks, 396 is Brandon. All right, let's move on. Next one. Oh, were you taking notes off of that? Okay. So that's what we've been doing with proportions. Now we're going to actually apply this to a real situation. Does anyone know, or does anyone know how to explain to me what a similar figure would be? Do you know what a congruent figure is? What are congruent figures?
Congruent is exactly like.
Congruent.
Similar is like has similar properties like similar things. It's not exactly the same, but it's like has some of the same things.
Okay, exactly. Congruent shapes are shapes that are the exact same shape and the exact same size. Similar figures are figures that have the same shape, they're just not the same size.
And what's
And-
the one that has the same size but not the same shape?
I don't know, would that just be different? It wouldn't be, I don't know. When we have similar figures, as we do here, these two triangles are marked as similar because of this. This angle has one tick mark in it. I call these tick marks here. This angle has one tick mark. That's saying that these two angles have the same measure. Okay? Then this angle has two tick marks. This one has two tick marks. Means they're the same measure. This one and this one both have the three tick marks. They're both the same measure. So are these two figures the same shape? Yes. So they're the same shape. They're obviously different in size because of the links on them. These are similar triangles. Similar triangles are proportional. Proportional meaning that their sides would line up and reduce down or expand out to be the same length. Corresponding sides of similar triangles are proportional. When you get to geometry as juniors, or hopefully before your senior year, but for sure by your junior year, there's a theorem in there that talks about corresponding parts of congruent triangles are congruent. And it's a CPCTC thing, and you'll hear it 1,000 times when you're in geometry. This is similar. Corresponding parts of similar triangles are proportional. So we can create proportions with this. Now, what does it mean to be corresponding? Anyone know what corresponding means? If I'm corresponding with someone in another country, what am I doing? I'm communicating directly with them, aren't I? I'm corresponding with them. Corresponding within geometry and math means that those sides, if I were to take this triangle and line it up with this triangle, they're the sides that match up. Okay, if they were the exact same size, both these triangles, it would be the sides that line up on top of each other. So the side opposite angle 1, here's your angle 1, and this side opposite corresponds with the side opposite this angle 1. So 6 and 3 correspond. Okay, they line up. 8 corresponds with 4, and then 4 corresponds with 2. They line up. Those corresponding parts are proportional. So I could take my 4/8 as a fraction, and that should equal 2/4, because the 4 corresponds with the 2, so I'm matching those up. The 8 corresponds with the 4, because they match up. What's 4/8 and 2/4 supposed to reduce down to? One half.
Yeah.
Okay. They equal each other. Okay, their proportions equal each other.
And the
Yes.
same thing with 6/8 and 3.
Right. You could go all the way around and write them different ways, and it's still going to work out right as long as you get the corresponding sides matched up. So corresponding sides of similar triangles are proportional. We're going to use that to solve for missing parts on similar figures. So we're going to start with x here. I take the variable I'm looking for, which is x, and I put it on top. Okay, I'm putting it on top of the fraction. What length do I know from that triangle? From the triangle that it's with? 3. I'm going to use that as my fraction. I'm going to take my value of x over 3. X and 3 are related. Think of this as family. Because they're from the same family, we know that I can connect them by writing a fraction of those. Now, I need x's cousin. Grant says 4 is x's cousin. Do you agree with that? Does it correspond with it and line up with it? Yes. So we can take this value of 4 because it's related to x as a cousin and put it over here. Now, is x's cousin's wife related to x?
No.
Only by marriage, but not by blood. It's got to be blood relative, okay? So, what would be the wife of 3 then?
X.
If we're looking at 3 here, what corresponds with that?
2.
2. They're related because they're cousins, and it gets weird and all that kind of stuff. Maybe even incestual a little bit. But line up related parts. Okay, now, do we have a proportion? Okay, so how do we solve for a proportion, Hattie? Butterfly. Good job, Caleb. Butterfly. So I always take my variable term first, 2x, and that equals 3 times 4 is 12. Then divide by 2. So the length of x would be 6. Okay. Now, let's solve for y. Again, taking the parts that line up. Want to solve for y, so I'm going to put y over. It still has 3 as a length, so I'm going to put y over 3. Now, what length in the other triangle is y related to?
5.
5. So I'm going to put 5 across from y. And what length is related to 3?
2.
2. Then do your cross products. 2y equals, and you have 5 times 3 is 15. Divide by 2 or multiply by 1/2, however it is that you want to do that. And you can leave it as 15 halves. If you write it as 7 1/2, that's okay. I'll take either answer. But it's just as easy to stop there and you don't have to do any more work than you need to. Okay? So set up the proportions by lining up matching and corresponding parts. Solving for n. First of all, we need to determine, Jasmine Mitchell, are these two triangles similar? Why?
They have the same
Ticks? They're the same shape, aren't they? Because of the tick marks, we know that they have the same shape, and that's what creates similar triangles. And if we have similar triangles, then they are proportional. So Clay, help me solve for m. Help me set up m first.
M goes with 9.
Okay, we can do that. That's not how we were doing it earlier, but it's okay because they're still related. I can put m with 9. And then what would I put across from m?
The 4.
The 4, because it's related to 4. These are the two values that it's related to. It doesn't matter if you put m over 9 and then put 4 across from it, or if you put m over 4 and put 9 across from it. Either way is okay, because it's related to both of those. Now what length relates to, what am I doing here?
Relates to 4.
Relates to 4.
Having a bad day.
5.
5. 5m. 5 times m, that's this cross product, is equal to 36. And 36 divided by 5. There's your length for m. Brandon Lee, help me set up solving for variable p.
No, I can't.
Yeah, you can. What's p related to? P over what?
4.
Okay, we can go p over 4. See, you can. So p is related to 4. What other length, Brandon, is p related to?
I'd say 5.
P and 5 over here. What about p
7.
and 7? Whoop, then I put it in the wrong spot. Okay, and then the length that's related to 4 again. Grant?
5.
5. Then do your cross products. 5p equals 28, and p equals 28 over 5.
If the first one you did is over 5, is the second one gonna be over 5?
Yeah.
Okay.
Yes, if you're only given one length in this tranche,
So
because the only one that relates to
It's
this one.
always this, like, it's always the number 5, like, it's always the number on the bottom of your second.
I wouldn't
fraction.
get too caught up in trying to figure out the rules for if this is this way and then this is this way, as much as make sure you line up things that are related.
Okay.
Alright? If you remember that, then you should be fine. And then you don't have to try to memorize all these different scenarios that way.